This is the video recording for homework 3, probability and stochastic process. Here we discuss the first question. The question setting is when px equals to k equals to b times k times p to the degree of k minus 1, where k is discrete numerical numbers and p is between 0 and 1. We are asked to find out the b so that p of x equals to k represents probability mass function. And for the second question, we are to find ex, and the third is to find e of x squared, and the next to find e of x squared minus e squared of x. And the final question is to find the conditional probability mass function. So considering this problem, we can first consider like a more general case where we discuss the sum of from k equals to 0 to infinity of the function p to the degree of k. It is obvious that we can get it to be 1 over 1 minus p, where p is between 0 and 1. And then as we know, we can notice from the probability mass function, there is a k in the as a scalar before p, and so we can try to take derivative of this function on both sides, and then to get a form of k times p. So the sum of k times p to the degree of k minus 1 is equal to take the derivative of the function on the right hand side. We get is 1 over 1 minus p to the degree of 2, and then we can multiply p by multiply both the equations on both sides by p, and to get this equation 3, which is like a more general case, and it's cohesive on the k and degree of k. And then we also solve for we can just directly solve for the value of b, where px is equal to b times k times p to the degree of k minus 1 to be a probability mass function, and this should be exactly equal to 1. And so we can get b is equal to 1 minus p to the degree of 2. And then for the second question, to find ex, we can just use the definition of expectation to get it to be the sum from k equals to 0 to infinity of the function k times p of x equal to k. And this is in the form of b times k squared times p to the degree of k minus 1. So we can similarly take the derivative of p on both sides of the equation 3 to get the square's term of k, and then we can get the sum of k squared times p to the degree of k minus 1 is equal to 1 plus p over 1 minus p to the degree of 3. And then we can also multiply both sides by p to get k. The sum of k squared times p to the degree of k is equal to 1 plus p, and the sum is multiplied by p over 1 minus p to the degree of 3. And thus we can get the expectation of e to be e of x is equal to 1 plus p over 1 minus p, which is this equation times the this function times the value of b, and this function's value is exactly 1 plus p times p over 1 minus p to the degree of 3. And there's also 1p should be multiplied to this function. And for the third question, we need to find e of x squared, and ex squared is exactly can be simplified to be the sum from 1 to infinity of b times k k to the degree of 3 and times p to the degree of k minus 1. And similarly, we also take the derivative of p on both sides of the fifth equation, and we can get this term is equal to the sum of this term is equal to 1 plus 4p plus p squared over 1 minus p to the degree of 4. So e of x squared is easily to get from this term multiplied by p, which is exactly 1 plus 4p plus p squared over 1 minus p to the degree of 2. For the fourth question, we can just deduct e squared of x from e of x squared to get then the final result we get is 2p over 1 minus p to the degree of 2. And the final question asks us to find the conditional probability of p where x equal to k and x is between 2 and 5. And we also have the value of p is equal to 1 over 3. So we can directly calculate out the value of b is equal to 4 over 9. And similarly, we can get p is equal to 4 over 9 times k p to the degree of k minus 1. And we rewrite this conditional probability mass function p where x equal to k and x is between 2 and 5 to the form where we both satisfies the condition of x equal to k and x between 2 and 5. We found that this probability and this probability divided by the probability where x is where the probability of x is from 2 to 5, and this is a sum of these four terms where x equals to different values, and we can calculate it out to be exactly the denominator is 4 over 9 times k times 1 over 3 to the degree of k minus 1, and we only need to calculate out the exact value of the denominator, and the denominator is approximately 0.5377, and just 1 over this term and times the term on the denominator is the final result we can get. And this is the when the probability is equal when k is not equal to any how to say this exact natural numbers, and the probability of this conditional mass function is exactly equal to 0. So we can just write it here as a line of p equals to 0 otherwise. And this is the end of this question 1.